The Higgs Boson Discovery, presented by Aaron Thistlethwaite. Let's start with some background information. Essentially, the world and everything contained in it, as we understand it in particle physics, is made up with particles within a larger field. For example, consider light, which is made up of both a wave and particle. The wave is on the electromagnetic spectrum, ranging from infrared to ultraviolet, with a couple others on either end of the spectrum. Importantly, visual light in the middle. Now, we have particles that bring the light to your eye, or the ultraviolet sunlight to your skin that burns you. So, this is a perfect example of having something that both consists of a wave and particles. Now, particles themselves have no mass when they are created, and instead, certain particles will gain their mass when they interact with the Higgs field. This field was originally proposed in 1964. So, particle types that we're going to be talking about today include electrons, neutrons, photons, and protons. Now, electrons, neutrons, and protons are particles that interact with the field and gain mass. Photons are part of light, and since light does not have any mass, we know that they do not interact with the Higgs boson field. The existence of our universe as we know it relies on these particles acquiring their mass from a fundamental quantum field. Before the discovery of the Higgs boson particle, scientists were working on describing a weak force using a framework called quantum field theory. So, what is the Higgs boson discovery? The Higgs boson discovery is the proof of concept for a mass-giving field's existence. This is a fundamental field that is made up of Higgs boson particles, which when interacted with, give other particles their own mass. It was previously understood that the Higgs field was responsible for generating mass. However, the particle was not discovered until 2012. And once that was discovered, that's the Higgs boson particle. The field is generated by particle collisions, and the resulting Higgs boson particles transfer their mass to protons, neutrons, and electrons as they pass through the field. How do we discover this? So, first thing that's really important to understand. The Higgs boson particle is not a particle that can be discovered in nature on Earth. The particle decays nearly instantaneously into the other particles around it, meaning that it's impossible to find in nature because we do not have the right circumstances to create them. It is only created in environments with a very concentrated burst of energy, such as a proton colliding with another proton in a hadron collider, or some other type of particle collider. That's not really important here. The point being is they can only be produced in labs and or possibly in space, but not in the nature of Earth. So, when two particles collide with one another, there are two factors of energy that are in question: mass and kinetic energy. So you have kinetic energy given by the speed, and mass given by the weight of an object. In particle collisions, kinetic energy can transform into mass, meaning that when you have two smaller particles colliding with each other, they may form one larger particle with less speed but more mass. Higgs boson particles are created in this method. So, how often do they happen? Well, I'm sure you've read this already by the end of this slide, but Higgs boson particles are generated by these collisions roughly 1 in every billion collisions, meaning they are exceedingly rare. How is it discovered? Part 2. The Higgs boson particle does not have a very long lifespan, as we previously mentioned. This makes them even harder to find than regular particles because they are not detectable by standard particle detector systems used in particle colliders. Due to this extra problem, Higgs particles are detected by analyzing data from billions of collisions. When Higgs is produced, there will be two electrons that are fired off of it with zero mass, but equal speed that adds up to the mass of the Higgs particle. We can determine this by analyzing billions of collisions and seeing if there's a peak in the diagram. If there is a peak in the diagram where there's more of a particular mass than others, it will mean that while most of them are randomly generated, there is a favorite of the bunch. This would be very similar to asking friends to pick a card when you leave the room. Maybe one of your friends has an affinity for the 9 of hearts. After 10,000 attempts, you're going to notice that while every card in the deck has been picked a certain number of times, there will be an abundance of the 9 of hearts when compared to everything else, even if they only did it, say, 40 or 50 times. So for this particle, when you analyze the histogram of the particle mass detected during collisions, the Higgs particle is discovered by the peak in the data being formed, which we notice by this arrow in this graph right here. Now, what makes this special? First of all, the Higgs field is responsible for every other particle in existence gaining its appropriate amount of mass, which is what allows the world that we know it to be a generated thing by different particles, because as we previously discussed, particles gain their mass when they interact with the Higgs field. Now, the stronger that interaction is, the more mass that particle will gain. This is why finding the Higgs boson particle is so important, because it is proof of concept for the existence of the Higgs field, without which all of quantum field theory would not function. Now, a couple things are specific as well. The Higgs boson particle is the only particle to have zero spin, as it is not magnetically charged. This is currently the only particle that has this distinction. Thank you for listening, and I hope you learned something. The Higgs boson particle is something that we will never interact with in your day-to-day life, but is a massive reason that your day-to-day life can exist. And just a couple of references that were used. Thank you.